Welcome back, Math 8. Today we are continuing our lesson on modeling equation. I like to say today is part 2. And when it comes to modeling equation, this is on page 27 of your Math 8 Linear Relationship and Equation booklet. So instead of going through online, I'm gonna do the traditional way. Instead of you guys clicking the link, find out the actual or constructing algebra tile and 2 equations from this side, I'm gonna create some random question like over here. 2a minus 2 is equal to negative 8. So now we're dealing with 2-step equation. Two-step equation involve more than one type of bad math, so it can be multiplying and adding, those kind of situation. We're going to do visual representation using tiles, and we're going to use symbolic method. I'm going to use color tile for positive, empty one for negative, something like that. One thing that you need to understand is when it comes to algebra tile model, it is important to have some kind of a scale. And on the left side, we put what I see on the left side, 2a. That means I have to have 2 strip colored. Remember, strip means variable like x. So 2a means 2 strip, and then negative 2, which means 2 empty tile. On the right side, we have negative 8, so that means 1, 2, 3, 4, 5, 6, 7, 8 of the tile. That's what you need to start first. Now, here's the thing. When it comes to 2-step equation, I want you to deal with integers, so in that case, constant value first. And obviously when it comes to visual representation, we're gonna do something I like to call zero pair. I have 2 empty tile over here. You want to get rid of this 2 tile. But in order to be fair, we need to do, or in this case, introducing 2 color tile on both sides. The reason I put in color tile so that those 2 colors are contradicting is so that I can make zero pair. And I can make that happen for the other side too. So after the first step, we're gonna have basically same type, but 1 color strip, another color strip, and I have 1, 2, 3, 4, 5, 6. 6 of the non-colored, which is what you see over here, these are placed on the right side. As you may notice, with that zero pair, we don't have any of the integer tile on the left side. We only have each of those variable strip left. Now, here's what we need to do. When we first deal with the integer, then we need to deal with our variable. But find one variable's value. What I mean by that is, right now I have 2 strips. Is there any way we can distribute this 6 empty tile to each of them? Yes, we do. We can combine these guys together, or we can combine these guys together. So long story short, from this process, we will deal with a situation where 1 color strip is equivalent as 1, 2, 3 empty integer tile. So that is a fancy way of saying A is equal to -3. Why don't we do the verification at the end? Let's do the other part. What about we are using symbolic solution? So that means we're using mental math situation. Then I like to start by putting our entire equation first. Then I'm going to focus on the side that I have variable, so left side, which is 2a minus 2, and I'm going to focus on the constant, like the advice that I put, minus 2. We need to introduce something opposite of minus 2, which means plus 2. Like that. From that situation, negative 2 part will be gone, so 2a is equal to negative 8 plus 2, which is negative 6. We have that situation. Simplify and rewrite it. 2a is equal to minus 6, something like that. Then we need to find one variable's value. So I got to get rid of this 2. 2a means it's fancy way of saying 2 times a. So opposite of multiplication is division. So 2 over 2, there cancel out. So a is equal to negative 6 over 2, which is negative 3. And as you may notice, both mental math method and my modeling method, they agree to each other. Now, verification is a fancy way of saying, in case if you forgot about it, we need to do substitution to double check. So that means a is equal to negative 3, we need to punch that number in here. So 2a minus 2, which is the 2 to the 2 times by negative 3 minus 2. That's what we're trying to find out. 2 times negative 3 means negative 6 minus 2, and we have negative 8. And as you may notice, my right side and my substituted answer, they do agree. So we are double checking our solution. This is how we do our two-step equation. Let's do more. As you may notice, I differentiated a little bit. I'm going to use tile method again to solve this. Negative 5x plus 10 is equal to minus 5. Try to find what's at x is equal to. And when it comes to the other two, I'm going to go through mental math method, because anything that involves division with the unknown variable, unfortunately, you cannot do any type of operation using algebra tile model. So let's deal with this one first. On the left side and right side, I have negative 5x, so that means empty strip, 5 of them. Like that. And 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Colored. There you go. We have negative 5x plus 10 on the left side, and negative 5, which is empty tile, integer tile, on the right side. My advice was, we have left side with the x over here, so unknown strips is over here. We need to get rid of this 10 tile. The way that you can introduce and get rid of it is introducing 0 pair, which means I have to have 10. Yeah, there's a lot, but 10 of empty tiles on left side and right side. Then magic happen. Everything cancels in terms of integer, and you will have the situation. Let's rewrite it. 1, 2, 3, 4, 5 strip with 1, 2, 3, 4, 5, 2, 3, 4, 5, 1, 2, 3, 4. We introduced 10, so we should have 15. There you go. Now our next job is dealing with one variable. So how many tile will be belong to one strip. Well, we have 5, so is there any way we can distribute the whole 15 into 5? Yes, we can. We can. Each distribute to one of the strip over here. Then you will have the idea that one strip is equal to 3 empty integer tau. That means negative x is equal to minus 3. But can you see that both of them has negative? So that means I can just get rid of the sign. X is equal to 3. When I say get rid of the sign, can you see that negative and negative, they can cancel each other by, let's say, negative x means negative 1 times x. Negative 3 is just negative 3. So if I divide by negative 1 on both sides, left side will be just positive x, right side will be negative 3 divided by negative 1, so just turning into positive 3. Which, long story short, if you see left side everything negative, right side everything negative, you can just change it to positive. But this doesn't work if you have positive and negative or negative and positive. If it's positive and positive, then life is good to go. This is how we do. Verifying the solution. Well, why don't we substitute? X is equal to 3 plus 10. So when we substitute to our expression on the left side, 5 times 3, that's negative 15 plus 10, give you negative 5. Do we have negative 5 on the right side? Yes, we do. Then we conclude that this equation's solution is x is equal to x is equal to 3. Now, next example. Hopefully this gives you a good idea because most of the time this is a good recalling. B over 2 and D over 4. Whenever you have a fraction means it's division. Unfortunately, when you're dealing with division having expression, especially when it comes to any unknown variable, sadly you cannot perform any type of modeling method. You need to do algebraic mental math method, ladies and gentlemen. So here's what we do. I want you to get rid of your constant first. So that means b over 2 minus 3, I'm going to put plus 3. Because if that happened, you know that b over 2 is equal to 7 plus 3, that's 10. Now, once that happened, know the fact that b over 2 is equivalent as b divided by 2. So if I multiply by 2, then these two guys will be cancelled because division and multiplication, they're opposite together. So long story short, if you multiply them together, we learn about fraction and multiplication, denominator and numerator. If they're equal together, they cancel out. So long story short, b is equal to 10 times 2, b is equal to 20. Let's verify the first one over here. B is equal to 20. So b over 2, if I substitute, so verify the first one, it's 20 over 2 minus 3 is what we need to do, which is fancy way of saying 20 divided by 2 minus 3. Bad math, we got to do these two pair first, which means 20 divided by 2 is 10 and minus 3. So my answer becomes 7. If we see 7 on the right side, our equation is on the right track. And yes, we do. So my solution for the two-step equation turned out to be 20. Next example, d over 4. Well, same thing. Get rid of integer or constant term in here first. So d over 4 is equal to negative 10 minus 2 is negative 12. It's like in the number line, you're going 10 to the left and 2 more to the left. So total 12 to the left. Then you guys notice d over 4 is a fancy way of saying d divided by 4. So I got to do multiply by 4 to isolate the variable. So that means multiply by 4 on both sides. Then now what we have is d is equal to negative 12 times positive 4. First thing first, negative multiplied by positive always give you negative. Opposite sign multiplication give you negative. Same sign like positive, positive give you positive. Negative, negative give you positive. So have that in your mind. So, D is equal to negative 48. Double check. Verify. When you're verifying this, we are going to try that D over 4 plus 2. So negative 48 over 4 plus 2. Negative 48 over 4 is negative 48 divided by 4. Negative divided by positive give you negative. 48 divided by 4 give you 12. So long story short, this is negative 12 plus 2, which is negative 10. And if I have that on the right side, we're on the right track. And yes, we do. We have it on the right side. So our solution is on the right track. That is today's lesson. Although equation, we did a little bit of review about Math 7 and how you learn about equations that time. It overlapped a lot in this section, so have that in your mind. Today's assignment question will be quite a lot compared to the previous lesson.